Welcome to a quick demo about how to use the example ADS control sources. I have loaded the file already, so I'm opening it. And here we have the organization, and please do not forget, if it's available, to always check the topmost DUT. Here it's mentioned, please see first macro readme, so we do so. Here we are, and it explains us the organization of this example. So obviously we have first 4 examples with nonlinear control sources, where the relationship between sense and controlled source is a polynomial, which can also be modified to a linear factor or even a constant. But what is important to remember here, the polynomial parameter values are real value numbers, so complex numbers are not supported. Now when we have, for instance, an equivalent schematic of a small signal MOS or HEMT transistor, we have a linear controlled source plus a phase shift or a delay. And this is then covered by the last example in this organization. So let me go back. Here obviously the 4 controlled sources with polynomial context, and here the special case of a linear controlled source with delay and GM. In all of those examples we have setups, and in the setups there is always a README transform which explains you what to do. So let me just follow this and show you what you can do. We stay with this example, so we first go here to the DUT. Here we have used the tab test circuit with a lot of explanations. First of all, this is the symbol of what we are going to have. It's a voltage controlled voltage source, and the sensing is between node 1 and 2. Then we have more explanations about how to set up the coefficients of the polynomial, and we have then further down a practical circuit example here. And it's a subcircuit. It starts with define, it ends with the end line here, and in between we first have to make a link to the library component of ADS, which covers this component of a control source, and then we have here the definition of the parameters we are going to use for the polynomial, and here the line which then defines the nonlinear control source. Here are the parameters: A, the constant, the linear context, and the quadratic context. Then we should have a look to the inputs and outputs. Here we are. We have a voltage which is sensed by this control source at node 1 to ground, which simply ranges from 0 to 1 volt. And we have an output which is then representing the control source at node 3 to ground. We also have a plot, so let me display this, and let's first reset all the results to 0, and then we are running a simulation, and here's the result, just to see how we can change that. For instance, we have another offset, like for instance 3.5, and then when we go again and simulate, then you see it begins at 3.5, and if we change the quadratic part, let's say we exaggerate a little bit, the quadratic is then 10 times the quadratic voltage, and we simulating again, then you see it looks different. So all the other examples are organized the same way. Every setup features a transform README, so please follow that and play around, and then copy paste the source you are interested from this test circuit to your own model file. Thank you for your attention.